The James Webb Space Telescope has revolutionized our understanding of the cosmos. Its recent discoveries have sent shockwaves through the scientific community, uncovering galaxies that seem to defy the very foundations of physics. Today, we'll dive into 3 galaxies so ancient and unusual that they challenge our understanding of how the universe works. Are we on the brink of rewriting the physics textbooks? Stick around as we explore these groundbreaking revelations and their profound implications for science and humanity. Just a year ago, renowned American physicist and science communicator Michio Kaku shared his fascinating thoughts on a groundbreaking discovery made by the James Webb Space Telescope. In an interview with NBC News, Kaku highlighted the detection of 6 primordial galaxies that defy our current understanding of the universe. To put it into perspective, it takes billions of years to form a galaxy like our Milky Way, which boasts 100 billion stars. But the Webb telescope identified 6 massive galaxies that existed just 500 million years after the Big Bang, and they're up to 10 times larger than the Milky Way. According to Kaku, that shouldn't happen. Galaxies that colossal simply shouldn't exist in the infant stages of the universe. This astonishing discovery has shaken the foundations of our cosmic theories, suggesting we may need to revisit our understanding of how the universe was born. While Kaku's insights initially raised eyebrows, subsequent findings from the Webb telescope have bolstered his claims, providing compelling evidence that challenges conventional models of galaxy formation. Earlier this year, the telescope uncovered a galaxy named Galaxies 13, which formed just 290 million years after the Big Bang, making it the earliest known galaxy. Another candidate, Galaxies 11, emerged about 500 million years after the Big Bang. These discoveries reveal a universe that, within its first billion years, was far more dynamic and productive than we ever imagined. It's as if the early cosmos was a bustling construction zone, churning out galaxies at an unprecedented pace. This revolutionary data could rewrite the story of our universe's origins. Galaxies and galaxy clusters have long been the building blocks of the modern universe, forming and evolving under the pull of gravity. But now, the James Webb Space Telescope has made an extraordinary discovery that challenges everything we thought we knew about the early cosmos. Meet the galactic red monsters, 3 ultra-massive galaxies that scientists are calling cosmic anomalies. Spotted in the infant universe, these monstrous galaxies are nearly as massive as the Milky Way and existed within the first billion years after the Big Bang. This groundbreaking find was made possible through Webb's FRESCO program, which utilized the cutting-edge NIRCom and NIRSPEC spectrograph to measure the distances and stellar masses of these early galaxies with stunning precision. The results, published in Nature, reveal a startling truth: star formation in the early universe was far more efficient than our current models predict. According to the favored theoretical framework, galaxies form gradually within large halos of dark matter. These halos pull in gas, creating gravitationally bound structures. But typically, only about 20% or less of this gas is converted into stars. So how did these galactic red monsters grow so rapidly and reach such immense sizes in such a short span of time? This discovery opens up a new frontier in our understanding of galaxy formation, suggesting that the early universe was a far more dynamic and productive place than we ever anticipated. The James Webb Space Telescope continues to uncover the universe's hidden secrets, reshaping the way we see our cosmic history. For years, scientists believed star formation in the early universe was a slow and gradual process. But recent findings are flipping that perspective on its head. New research suggests that massive galaxies in the early universe were far more efficient at forming stars than their later counterparts, growing at rates that exceed anything previously imagined. Thanks to the unparalleled capabilities of the James Webb Space Telescope, astronomers can now peer into the farthest reaches of the cosmos, gaining fresh insights into the mysterious, dust-filled galaxies of the early universe. One of the Webb telescope's most striking revelations comes from the FERESCO survey. While most of the surveyed galaxies align with existing models, the data also uncovered 3 outliers, ultra-massive galaxies with stellar masses comparable to today's Milky Way. These galaxies, nicknamed red monsters for their vivid red hues in Webb's images, owe their color to their high dust content. What's even more astonishing is their star-making efficiency. These red monsters are forming stars at nearly double the rate of smaller galaxies in the same era, or even those from later periods. Dr. Shaw, lead author of the study, explains, the massive properties of these red monsters were barely understood before. Now, our findings are reshaping our understanding of galaxy formation in the early universe. This groundbreaking discovery not only challenges existing theories, but also highlights just how dynamic and complex the cosmos was in its infancy. The James Webb Space Telescope is truly rewriting the story of how galaxies and the universe itself came to be. The James Webb Space Telescope, JWST, has made a stunning discovery: massive galaxies that are optically invisible due to dust attenuation, as Dr. David Elbez explains. While these observations align with current cosmological models, they raise new questions about galaxy formation, particularly the existence of too many and too massive galaxies so early in the universe's history. To explain the presence of these giant galaxies with highly efficient star formation, scientists may need to rethink existing models. Something extraordinary must have driven such rapid development in the early cosmos. What makes these massive galaxies so surprising is that they exist so early before we thought they had time to form, says Erica Nelson, an assistant professor in the Department of Astrophysical and Planetary Sciences. It's like coming home from work, expecting to find your kitten, only to find a cougar lounging on your couch. Nelson, who helped identify several of the red monsters in a 2023 study, says the new research digs even deeper, confirming these galaxies are as old and as massive as they appear. Somehow, these galaxies managed to turn nearly all of their gas into stars in just a few 100 million years, an astonishing feat that demands a new understanding of how galaxies can form so quickly. Just a few 100 million years, the blink of a cosmological eye, as one scientist from the team put it. This short time frame is where some of the most extraordinary cosmic discoveries are unfolding. With future research using the James Webb Space Telescope and the Atacama Large Millimeter Array, ALMA astronomers are poised to unlock even more secrets about these ultra-massive red monsters and possibly uncover additional examples of these early cosmic giants. Speaking of ALMA, there's another mind-blowing discovery that's rewriting everything we thought we knew about galaxy formation. A galaxy called Rebels 25, found by the ALMA telescope. This distant galaxy, which formed just 700 million years after the Big Bang, looks remarkably like our very own Milky Way. It's a massive, disc-shaped galaxy, complete with hints of spiral arms and even a central bar features we typically associate with much older galaxies. How could such a well-structured galaxy exist so early in the universe's history, when everything was supposed to be chaotic and unsettled? Further observations revealed that Rebels 25 isn't just any ordinary early galaxy, it's actually the most distant, strongly rotating disk galaxy ever discovered. To confirm these incredible findings, astronomers took a closer look with LMA's high-resolution data. What they found was nothing short of revolutionary. Not only does Rebels 25 have a rotating disk, but its structure and dynamics challenge our entire understanding of galaxy formation in the early universe. This discovery is leaving astronomers scratching their heads, eager to uncover how galaxies like this could form so quickly and evolve so efficiently. The discovery of Rebels 25 also hinted at other advanced features, like a central elongated bar and the possible early formation of spiral arms characteristics more commonly seen in mature galaxies like our Milky Way than in one born so close to the Big Bang. So, what does this mean for our understanding of cosmology? The discovery of Rebels 25 is shaking up everything we thought we knew about the early universe. It suggests that galaxies may have formed and evolved much faster than previously believed, opening up a world of exciting new mysteries about how galaxies were born and grew in the cosmos. But the real bombshells came in October 2023 and January 2024, when the James Webb Space Telescope uncovered massive galaxies dating back to the very beginning of time. Recent analysis of these discoveries points to a startling reality that could drastically change the course of modern astronomy. According to the standard cosmological model, galaxies were thought to form around 200 to 500 million years after the Big Bang, emerging from dark matter filaments that began to cluster across the universe. These early galaxies were expected to be small, gradually growing over billions of years through mergers and other cosmic processes. But the existence of these colossal galaxies so early in the universe's history raises serious questions. How did they form and grow so quickly? These discoveries are forcing scientists to rethink their theories and challenge the very foundation of galaxy formation. The universe may be far more dynamic and complex than we ever imagined. In the early stages of galaxy formation, scientists thought the process of merging and accreting gas and dark matter would take billions of years. For a galaxy like our Milky Way, it was believed to take between 1 to 2 billion years to reach adolescence. But then, in 2022, a groundbreaking study from the Cosmic Evolution Early Release Science Survey (CEERS) used the James Webb Space Telescope (JWST) and its NIRCom instrument to peer back to a time just after the cosmic dark ages, a period when the universe was still young and chaotic. What they found shocked them. Instead of the chaotic, fragmented galaxies they expected, they discovered far more galaxies than predicted, larger and brighter than anyone thought possible. According to our most accurate models, galaxies shouldn't have existed at such an early stage, let alone appear as fully formed and luminous as these did. But it didn't stop there. In 2023, JWST dropped another bombshell. The telescope revealed several massive disk-shaped galaxies that formed just 400 to 600 million years after the Big Bang, completely defying 99% of theoretical predictions. Data from the Hubble Space Telescope suggested that disk galaxies like ours didn't emerge until the universe was about 6 billion years old, yet the Webb results pushed that timeline forward by billions of years. These discoveries are rewriting the book on galaxy formation, forcing scientists to rethink the timeline of our universe's evolution. Since the dawn of the universe, scientists have struggled to explain how galaxies could form so early, and there are several theories on the table. Some suggest the earlier formation of supermassive black holes, while others point to the effects of frequent supernovae or even the influence of dark energy. But despite all the possibilities, a definitive answer remains elusive. And that's just the beginning of the story. In early 2023, scientists working with the James Webb Space Telescope, JWST, as part of the Advanced Deep Extragalactic Survey, JADES program, made an astonishing discovery: a very, very old galaxy that would shake everything we thought we knew about the early universe. They named it JADESGS C114, and it had a companion galaxy, JADESGSA 1141, located nearby. Then, in October 2023, the JADES team took things even further. They performed deeper imaging, followed by a 75-hour campaign of spectroscopic observations that confirmed something mind-blowing. JADESGS C114 is the oldest galaxy ever observed, forming just 290 million years after the Big Bang. And its companion, JADESGSE 1141, was almost as far away. What makes this discovery even more extraordinary is that JADESGS C114 isn't just ancient, it's also massive and incredibly bright. Further analysis revealed something even more surprising. The stars within this galaxy are about 90 million years older than initially thought, meaning they formed only 200 million years after the Big Bang. The data also revealed that the galaxy's intense light is a clue to just how quickly it began to evolve, pushing the boundaries of what we thought possible for the early universe. The mystery deepens with the discovery that the light from this galaxy doesn't come from a central black hole, as scientists expected. Instead, it radiates from a halo of young stars surrounding its core. Researchers believe the light is driven by bursts of new star formation, which they estimate have been happening since about 200 million years after the Big Bang. But the surprises don't end there. The galaxy also shows unexpectedly high levels of dust and oxygen, suggesting it has a long history of star formation and stellar death, far more than we'd anticipated for a galaxy so young. Here's the kicker: this record-breaking galaxy might not hold the spotlight for long. Scientists are now speculating that there could be even older galaxies lurking in the early universe, waiting to be discovered. In a bold quest to unravel the mysteries of the early universe, a team of astronomers turned their focus to three massive galaxies, now known as the Little Red Dots. These galaxies were emitting light from stars that seemed shockingly old, a discovery that would shake up everything we know about cosmic evolution. These galaxies appeared to have formed just 700 million years after the Big Bang, and they looked nothing like anything we see in the modern universe. While 700 million years might seem like a long time in the context of the universe's 13.8 billion year history, these galaxies were already in existence when the universe was just a mere 5% of its current age. But here's where things get even stranger. When scientists analyzed the intensity of different wavelengths of light coming from these little red dots, they found something stunning. The stars in these galaxies seemed to be hundreds of millions of years old, far older than expected for a galaxy so young. According to our current theories, stars of that age shouldn't even exist so soon after the Big Bang. And the surprises keep coming. The researchers also detected signs of supermassive black holes in the regions around these galaxies, black holes that are thousands of times more massive than Sagittarius AE, the supermassive black hole at the center of our own Milky Way. As scientists delve deeper into these strange and distant objects, it's becoming clear that our understanding of galaxy formation and the very early universe itself might need a serious overhaul. Spectroscopic data confirmed that these galaxies are from the very dawn of time, revealing something astonishing. The intense light output of the red dots is powered by overgrown supermassive black holes and unexpectedly old stars. This discovery challenges everything we thought we knew. It suggests that these galaxies are either far older and more massive than the Milky Way, having formed much earlier than predicted, or they have normal mass but host extraordinarily large black holes. What truly sets these primordial galaxies apart, though, is how they defy expectations in size. Despite having nearly as many stars as our Milky Way, they appear significantly smaller. To put it in perspective, if the Milky Way were scaled down to the size of one of these red dot galaxies, our nearest star, Proxima Centauri 4.2 light-years away, would be located within our solar system. Even more mind-boggling, the distance from Earth to Sagittarius AE, the supermassive black hole at the heart of our galaxy, would shrink from 26,000 light-years to just 26 light-years. This would make it visible in the night sky, something truly mind-blowing for anyone looking up from Earth. "It's very confusing," said Joel Leah, an astrophysicist at Penn State and one of the scientists behind the discovery. "You can make it fit, but it's uncomfortable. Our current understanding of the universe doesn't quite fit these luminous red dots, but that might only be because we need to invoke something extraordinarily exotic, an insanely rapid formation at the dawn of time." While the standard model of cosmology and galaxy formation has been remarkably successful, these mysterious objects don't seem to slot easily into our established theories. Welcome to Blessovia Science TV, where we take you on an exhilarating journey through the cosmos and unravel the mysteries of science. We are excited to offer you the opportunity to become a valued member of our ever-growing community of cosmic enthusiasts and knowledge seekers. Exclusive access to cosmic content. As a member of Blisovia Science TV, you will gain exclusive access to a treasure trove of cosmic content, including documentaries, interviews with leading scientists, space missions updates, and awe-inspiring visualizations of the universe, live Q, and sessions with experts. Your membership will grant you the chance to participate in live Q and sessions with renowned scientists, astronomers, and space explorers. Get your burning questions answered by those who push the boundaries of human knowledge. Embark on a journey that spans the cosmos and join us in unraveling the secrets of the universe. Become a Blisovia Science TV member today, and together we will reach for the stars. Thanks for watching. Subscribe, like, and share. Don't forget to leave your comment.